Alright, what we're looking now is a dual trace screen. The top signal is here's my top signal right here. This top signal is my cam sensor. It's not showing the whole revolution, but it's my cam, it's my crank. It's a dual channel lab scope. Now the thing with a dual channel lab scope, you can see mechanical faults. For example, you notice how each of the cam signal slots, which represents a certain position inside the cam sensor, on the cam sensor itself, falls right in between every 4 slots, like so. It falls right in between the crank. Oh yeah, I forgot to tell you, this is a crank signal. These 4 pulses from the crank, the RPM input to the PCM. These four symbols represent the RPM signal on crank position, crank position for RPM, engine position for the cam's engine position for find the coils. That's your cam sensor. And you noticed these things fall right in between each individual 4 signals. This is how it's synchronized. Now, this is a good signal. If I had, let's say, a jump timing belt, or somebody installed a timing belt wrong, I would see these signals push over either this way or this way. I think it's retarded. This way. It'll be pushed over, and these signals here will not be aligned in the middle like this. So I had this set up, and I seen this signal moved over this direction. Sometimes I think it's this direction here. I think this is the retard side. Either or. One's mechanical part going one way, and somebody installed it wrong the other way. I just forget which one is which. But I think this is retarded this way. So anyway, if the timing chain had jumped, these signals would not be in the middle of this crank as you see it here. It would be actually on top on one of these notches here, indicating you got a jump timing belt, or the timing belt was installed incorrectly. So basically what I'm trying to say is a dual trace lab scope can tell you a mechanical problem. Okay, let's go look at something else. Okay, this is a Honda fuel pump circuit on current. As you see here, it's averaging about 3 amps. I'm using an amp probe to check a mechanical problem with the fuel pump. As you can see, this looks pretty good. Okay, you can see the arrows pointing to the lines. When it peaks up, the brushes and commutator are lined up. When it falls down, the brush is not lined up with the commutator, and then you're seeing the repeated signal. Now, every car may look a little different. You have to get to know each individual manufacturer. But the main thing you're looking for, okay, what you're looking for when you see this is uniformity and the amperage draw. Okay, this can actually tell you you've got a weak pump or a pump that's gone out, but you need to know the specs on the RPM for each manufacturer. But what can stand out to you really nice and clear, if one of these lumps here all of a sudden shoots up. If one of these lumps all of a sudden shoot up here, or anyone, they just all of a sudden shoots up. Every time it rotates, boom, shoots up, boom. It could tell you that you have a shorted winding inside the fuel pump armature. That could be any type of motor. So again, you're looking for a uniform pattern, how much amperage is drawn, and if you notice one of these humps that suddenly shoot up, it indicates you got a shorted pump. Next one. Now let's look at this one. Let's look at this. Here's a injector current here, and this other one, the yellow one, is my primary circuit. Okay, it's my voltage to the primary. It's being pulled to ground. Right here, it's saturating the coil, and I'm releasing the ground. I'm firing the coil here. And here's my injector at that same time. This injector is drawing about 8 amps. 8 tenths of 8 amps. 8 tenths of an amp. Okay. Now one thing about this is a good pattern. But one thing I want you to look at right here. Indicating my injector pintle came on. Open up. Okay. You had the car had a misfire and this was a straight line. It can indicate you got a stuck closed injector. Now we look at this one. Now this is an injector and this is the injector. Let me see. Oh yeah, injector voltage, which looks good, and the current on it. Oh, one thing I forgot to mention also. You see how this slants up? That's what you're looking for also. This slant. Right here, you can see a little bit when the pintle open. But right here is another thing. You want that nice slant right there. If it goes straight up and across, shorter injector. This slant overcoming resistance. So you want to see that slant. You want to see a little dip here. You can barely see it here, but it's a little bit right there. Right? And how much current is pulling. So that looks pretty good. Also here, there's my voltage going to an injector. There's my voltage going to the injector. Being pulled to the ground, my injector's being held open. I have my pulse width turned off and back down to system voltage again. So here to here is my pulse width. And here's the current being drawn. Alright, this is my current being drawn on this one. So in this case here, scared the dog. So in this case here, okay, my injector's opening, pulling current. You got a good voltage to it. You can see right here, it's my voltage about 13 volts. Pulling the ground control, being turned off, back down system voltage. We can't see the top of this. And sometimes what you want to look at also for a bad injector is where it peaks at. But this injector is pretty good because it's going to slant here, not pulling high current. About a little less than an amp and a half. So that's good. So that's a pretty good picture. Alright, so this is verify that my amperage is good and the voltage is good. Alright, that's it for this. Good luck in your test. Let's see how this works out. Peace. I'm out.
What she did?